Hey everybody, today we're going to be looking at the volume of non-revolution solids using calculus. Well, by this point, I'm hoping that you have at least somewhat of a grasp of area of using calculus. Well, now let's try to get into volume. Volume is a little bit more tricky than area. Let's start with a graph, shall we? Do this graph right here. This right here of negative x plus 8, and this equation for x squared plus 2x plus 1. And we're going to be looking at right here. And because we're going to need to know this, they cross at about x equals 1.54. Okay, well, say they give you this and they tell you, now, this is the base of a square, not just one square, an infinite number of squares in between these points. Now find me the volume of it. Okay, well, let's get right into this. Now what they're telling us is this is the base basically. So it's going to be bigger at the end over here, and then it's going to get smaller. Okay, well, how are we going to find this? Well, we knew when we were finding area, we were working in 2 dimensions. Well, volume is just in 3 dimensions. I mean, that's why we get cubic centimeters and all that science stuff that people like. Well, let's try to use that in here. We know that 1 dimension can always be the integral. In this case, the integral from 0 to 1.54 dx. But what would our other 2 be? For area, we were working with the graph of the height. Well, that graph can still help us here. Can help us a lot actually, so why don't we get it again, which is top minus bottom, x squared plus 2x plus 1, that comes out to a nice negative x squared minus 3x plus 7. That's the graph of our height in between these points. But now we know that the distance in between here, which is our height, which is what we found here, is also the base of a square. Well, what do we know about area of just a normal square? Well, it's side squared. And if what we're finding is the base of a square, we're finding this value right here. So all the sides are the same, so we just need to take that and square it. And now this is the graph of the area of all those squares through those points. And area is in 2 dimensions, so we just need one more dimension, which is our integral from 0 to 1.54 dx. Do not forget the dx. And there we go. That's how we do it if they told us squares, but what if they told us something other than squares? What if they were feeling particularly mean today? They said rectangles. Rectangles with a width that's 5 times its length. Well, we're still finding this right here. We're still finding the length in this case. So width is just 5 times the length. Wouldn't we really just have to put a 5 out front? Yeah, that'd be about it. Because we know that length times width is how we get rectangles. We know that we can find length in our equation, so let's just call that z, because I feel like it. And we know that for every one value we have for length, it's going to be 5 times that for width, so it'd be z times z to the 5z, and then we'll just basically end up with 5 times z, so 5 right out the front. Well, what if they're even more mean than that? They're like, you know what? I had a bad day, so I'm going to make you find the volume of this if it was made of semicircles. Whew. Well, that gets a little bit more challenging, but still the basic concept. We know a semicircle is 1/2 pi r squared. Okay, and we know that what we're finding now is basically this right here. Well, this isn't the radius, so it doesn't work perfectly into this equation. We're finding the diameter with this equation we have right here. Well, diameter is just 2 times the radius. Or in this case, so we can just change it. Change the equation to work for us. Change it to be 1/4 pi d squared. And then when we put it together in our big equation, we have 1/4 pi on the outside because it makes it a little bit easier. 0 to 1.54 negative x squared minus 3x plus 7 squared dx. And that's how we do it for semicircles. Really, the thing you need to understand about finding volume of non-revolution solids, when they give you a shape, you need to find the area of the shape, understanding that when you do top minus bottom, you are getting the base or the height or whatever, and just molding the area formulas you already know to work with your new units, to work with what you can find. And then just doing simple integration. That's really all it comes down to. Have a good day.